Now we will be discussing the mutual inductance. This is one of the important concept, mutual inductance. So let's say two inductors are there. So two inductors are there. The self inductance is L1 and for this coil L2. And the voltage across those inductance is V1. Here it is V2. And the current flowing through this inductance, here it is I2 and here it is I1. Okay, now in this particular coil, in the coil number 1, the flux linkage is phi 1 and that is L1 into I1. But because of this particular coil, there will be some flux which gets linked in this coil also. So because of this coil number 2 and the current flowing in this particular coil number 2, we will be having some flux linkage in L1 also. So that total flux linkage phi 1 in this L1 or in the coil 1 is L1 I1 plus some constant into I2. Similarly, for coil number 2, the total flux linkage will be L2 I2, that is for the self inductance, plus some constant into I1. Okay. So this L1 is self inductance and this M2 is called mutual inductance. Okay. Now if I further write the equation and if we get the equation for voltage, then we can get V1 equals to d dt of phi 1 and here we get the voltage is d phi 2 dt. Okay, now if I further express it with respect to inductance or current value, then it becomes L1 di1 dt plus m d dt of I2. Similarly, for V2, we get the equation like this: L2 d dt of I2 plus m mutual inductance d dt of I1. Okay. Now, with respect to the direction of the current in different inductors or different coils, this mutual inductance can be positive or it can be negative. And how to determine when this mutual inductance will be positive, that is the flux is additive, or when this mutual inductance is negative, that is the flux is subtractive. We need to find out that one. For that, we have to understand the concept of dot convention. What you have to understand, that dot convention, it is one of the most important topic and lot of question comes with this particular dot convention from. Okay, so how this or what is the dot convention? Let's say we are having two inductors like this way. Okay, here it is L1, it is L2, and the mutual inductance between these two particular inductor is M. The mutual inductance is M. Now we have to define some dots. Okay, we have to define some dots, and we have to check with respect to passive sign convention that whether those currents are entering into the dots or whether this current are leaving into the dot, leaving from the dots. So let us again draw this. Okay, let us again draw this. First, let me clear all the canvas. Let us again draw this. So let's say this one is the first inductor and this one is the second inductor. Here the self inductance is L1, here the self inductance is L2. Now I have put two dots here, arbitrary dots you can say, and in the circuit the voltage is like this, and the with respect to the passive sign convention the current is like this. Okay, now we can say, and with respect to this dot the mutual inductance is M. So you can see that with respect to the voltage and current, the current is with respect to the passive sign convention, the current is entering into this particular nodes or particular dots. So for both the cases the current are entering into this dot, so we can conclude that this mutual inductance is positive. So here the mutual inductance will be like this, that is flux 1 will be L1 I1 plus M I2, and flux 2 flux linkage phi 2 will be L2 I2 plus M I1. Okay, now let's say the flux linkage or dot convention, with respect to dot convention, these are the dots. The mutual inductance are similarly M. This is L1, this is L2. Here it is plus V1, and as per the passive sign convention current is flowing in this direction. Here the voltage is opposite, so it is V2. So as per the passive sign convention current will be flowing in this direction, I2. Okay, now here you can say in this particular coil the current is entering the dot, but in this particular coil current is leaving the dot. Okay, so as the with respect to the dot, in one dot the current is entering and in the other dot the current is leaving, so the mutual inductance M will be negative. Okay, so here the flux linkage phi 1 will be L1 I1 minus M I2. Similarly, for second coil phi 2 will be L2 I2 minus M I1. Okay, so this is one of the important concept with respect to mutual inductance, and that has to be remembered.